Okay, so for question 4, we want to start off at least as a normal distribution question. So we're looking at the stopping distances for bicycles traveling at 20 kilometers per hour, and they follow a normal distribution with mean 6.76 meters and standard deviation 0.212 meters. Under this assumption, find correct to 4 decimal places. That's important, guys. So as I say, look, write down or underline this, 4 decimal places, this. Less than 6.5 meters. Okay, so this, guys, I think is not difficult. So I'm going to do the probability. We can just go with x is less than 6.5 is equal to. Take out your calculator, menu, probability, distributions, normal CDF. Our lower bound is like minus infinity, which is already there. And our upper bound is 6.5, so that'll be less than 6.5. Our mean, we know, is 6.76. And our standard deviation is 0.12. Press OK, and we get 0.01513. 0.01513. He says find correct to 4 decimal places. So guys, you have to go with 0.1234. That's 4 decimal places. More than 7 meters. That's the probability that x is bigger than 7. Okay, same thing. Menu, probability, distributions, normal CDF. This time our lower bound is 7 and our upper bound is infinity. I'm just going to put 9999999. That's definitely enough 9s. 6.76. Standard deviation 0.12 again. Press OK. 0.02275. 0.02275, which is approximately equal to 0.1234. And our 7 now has to get rounded to 8. That is 4 decimal places. Okay. Part B. 1,000 randomly selected bicycles are tested and their stopping distances are measured. Find correct to 4 significant figures. The expected number of bicycles, spelled wrong. I'm missing a Y in there, whatever. Bicycles tested that stop between 6.5 and 6.75 meters. Okay, so first I need to find the probability that x is between 6.5 and 7.75. This probability is 6.5 and 7.75. You can do this too, guys, if you want. You can just copy and paste this and change it here to 6.5 and then 7.75. And then this is the mean and this is the standard deviation. So this is 0.98, 0.98487, 0.98487. That does seem quite high to me. In fact, that's impossibly high because I put in the wrong number. 6.5 and 6.75, 6.75, sorry. So let's do that again. I'll press paste and I'll do 6.5 and 6.75. And I get 0.451663. 0.451663. Find correct to 4 significant figures, right? So now this is the probability that they're between 6.5 and 6.75, but we need to find the expected number of bicycles out of 1,000. So I just do 1,000 times 0.451663, and that gives me, I can do that without a calculator, guys. It's 1, 2, 3. That gives me 451. .663, but he says correct to 4 significant figures. So I'm going to say equals 451.7, and I'll just write 4 significant figures in brackets there. So that's the expected value. No, you don't have to round it to 452 or anything like that because it's number of bicycles. That's the expected value, and that's fine. Second one, I'm just going to do it the exact same way. This is now the probability that x is between 6.75 and 7. So same thing here, guys. I'll just copy this. 6.75 and 7. Zero 0.510457, 0.510457. Same thing, 1,000 times 0.510457. That is equal to 510.457, which is 510.5. I have to round this up because of these two. And this is to 4 significant figures. Okay, that's parts A and B. 6 marks. Again, if you know how to use your calculator, not a difficult 6 marks.